experiment 5B and 5D. 5C, I don't have copper sulfate, so we're leaving that for the time being. It just works out to be obeying Ohm's law. We'll come back to it in September. Okay, so 5B is to draw an IV graph to investigate the relation between current and voltage for a filament bulb. Okay, and then 5D is to investigate the relation between current and voltage for a diode and we're going to do at this stage in forward bias. We look at the reverse bias version later when we're doing semiconductors. Okay, so same setup as before. Okay, so for the filament bulb, first of all, okay, so it's exactly the same. So we'll just run through it just to remind you. Okay, so you have your potentiometer, your power supply. You're going from there to the ammeter. Now this time it's a milliammeter, so put in that for a milliammeter because the current will be small. Okay, we have a filament bulb. Okay, symbol like that. Okay, and back around to there, and we have our voltage across the filament bulb as before. Okay, when I do the experiment, I'll have a color code the same as previously, just to remind us. Okay, but you're happy enough with that. Now, in this case, we're going to bring the voltage from 0 to 10 volts. Okay, so your table will go from 0 to 10. Okay, so voltage in volts, current this time in milliamps, and that's going to be important for when you're getting resistance at the end. Okay, and you're going from 0 to 10, so, and you're going to find the current. Okay, now I'll let you know the secret. It's not a straight line graph through the origin. Okay, you're going to end up with something like this. Okay, remember that's in milliamps. Okay, it's in milliamps. That'll be important in a minute. Okay, so you draw the graph. Okay, and it will look like that. Okay, so what we're going to do is at 1 volt and at, let's say, 8 volts, we're going to find the resistance. There's a few ways of doing this, but we're going to do it the posh way. Okay, in that you're going to draw a tangent. Now you know what a tangent is, a line which touches the curve at one point only. Okay, so you're going to draw a tangent. Okay, here, and you're going to draw a tangent there. Okay, and then you're going to take 2 points on each of these. Okay, 2 points on each of these, and you're going to find the slope and then the resistance. Now you have to be careful. Okay, when you're getting the slope. Okay, right. Put your current in amps, right? Not in milliamps. Okay, put the current in amps, not milliamps. So if you're putting in a value of 46 milliamps, put it in as 0.046. That's probably the easiest way to do it. And remember, you get the resistance as 1 over m in both cases. Okay, so you're going to, so let's get clear on it. At 1 volt, you're going to draw a tangent. Okay, so a line that touches at 1 point only. Now it's going to be hard to draw that accurately, but it doesn't matter. Okay, and here we're going to do it again. Okay, at 8 volts, right? Okay, so for both of those, you're going to find 2 points fairly far away on the line because you want to reduce percentage error by beating large values. Isn't that right, Sean? Okay, and we're going to get 2 resistances. Okay. Clearly, the graph isn't going to be a straight line graph through the origin. It's not going to obey Ohm's law. Sorry about the cough. Okay, and we will, you will write that down as well. Okay, so that's the first one. Okay, you're going to do that. Okay, don't worry about drawing in this. All you need to put in here now is 5B filament bulb, and then the table, the graph, and finding the slopes and explaining the graph. Okay, now. Then the other one, which you're also going to do, is the diode in forward bias. Now the diode in forward bias, diodes do not allow a large current to flow. Okay, so we're not going to have a very large voltage, and we're going to only go up as far as 0.8 of a volt. Okay, now this time, okay, right, this time it will be important to be clear on our colours. Okay, so we're going to change a little bit this time. Okay, in that the positive is going to be the red. Okay, so we have our power supply, we have our variable resistor or potentiometer, again we have a milliammeter, we have a diode going that way, okay, and we have the voltmeter. Okay, so in this case, right, the positive is the red, okay, and we're going to use red, okay, all the way to get into the positive end of the diode. The positive end of the diode is the triangular end, okay. And the negative end is the black, so we're going to use leads, black leads, to do that. Okay, and we will use blue leads again to get for the voltmeter to keep it okay? But what's important here is that the negative end of the power supply should be connected to the negative end of the diode, and you know the negative ends of a diode because in a diode, I'll just draw it here, diode will be just a little cylinder, there is a silver line at the negative end, okay? So we'll have it in forward bias, okay? Your table, again, voltage, measured in volts, and this time you're going up in points, okay, of a volt, and the most we'll get to is 0.8 if we're lucky, okay, and the current again will be in milliamps, and we'll get our values. You're going to draw a graph of voltage against current, and this time we leave it to you as a surprise to see whether it obeys Ohm's law. Again, if it's not a straight line, you're going to be drawing a smooth curve, okay, a smooth curve, but we'll wait and see. Okay, so step 2 now is we're going to do the experiment. So you're going to draw your 2 graphs, do the work as I've indicated, and then we will we'll go through the notes as well on it. Okay, thanks.